So we're now going to move to our next presentation. As big data and the Internet of Things changes everything from where people go, how they get there, and what they are doing, one thing is clear. The future of the automobile and transportation in general will be data-driven. At the forefront of this will be connecting cars to smarter cities. To find out what mobility in the future could look like, please welcome our next presenter to the stage, Mr. Brian Mistelli, co-founder, president, and chief executive officer of INRIX. Thank you very much.
Good afternoon. You know, it's interesting. I've been listening to a lot of the different speeches today, and I think everybody has the same common theme, and that is this industry is changing. Although for those of you who've been to this conference for a while, and I've been here since the first conference when it was only about 4 tables, we've been hearing that for a long time, haven't we? Right? This industry is changing. The car is going to become connected. We've heard it over and over again. And in fact, it is changing. I mean, I've been in this industry a very long time. A little history. I was actually the Ford family's paper boy when I was 8 years old. So starting from there, I had a very good appreciation for the car industry and have kind of grown up in it. But now we're talking about ride sharing, we're talking about connected vehicles and everything else. And I think all of us are very familiar with those things given the background of the folks in this audience. But I want to talk about something very different, and that is the connected city. Because the connected car and the connected city go hand in hand. Now, for those of you who don't know INRIX, let me give you a little background. Now, we've been in this business for about 10 years, and INRIX today started with a very simple idea, and that was, can you crowdsource traffic data from vehicles out on the road? And today we aggregate data from more than 185 million vehicles and devices in real time. So 185 million daily active vehicles are providing data to us from their vehicle systems over a connected device to INRIX. In addition to mobile phones and other things that we collect information on. And we use that to provide traffic data today in more than 40 countries. In fact, we provide data to most of the OEMs in this room, folks like Ford and BMW and Toyota, Audi, Tesla, and many others. But over the last several years, we've now provided a variety of other content as well, things like fuel price information, dynamic fuel price information, dynamic parking information, weather information, and things like that. But as we've done that, I think it's put us in a very unique position to see, there's the clicker. It's put us in a very unique position to see how things are evolving. We provide data, in addition to providing data to OEMs, we provide it to more than 60 cities and government agencies now worldwide. And the question is, what happens with the data? You know, TomTom, our good friends at TomTom, once did a study about 2 years ago and said, if only 10% of the vehicles on the road could be connected, you could fundamentally reduce traffic congestion by more than 5%. That sounds pretty good, doesn't it? Just connect 10% of the vehicles on the road, and you can reduce congestion by 5%. It sounds good, but here's the problem. ABI Research said that about 11% of vehicles last year were connected. And we saw in the same period congestion go up by 6%. So something's fundamentally broken, isn't it? And the question is what? The Center for Economic and Business Research out of London did a study, and they said there's a real economic cost for traffic congestion. In the United States, UK, France, and Germany alone, they estimate about $200 billion in direct costs related to congestion. So this is more than just a hassle. This has a real economic cost on our cities. If you look at the United States alone, the cost is about $120 million, or about $2,000 per family. In direct costs, fuel wasted, productivity lost by sitting in traffic congestion. But the key is this. If you look at the TomTom study, what they failed to recognize is getting data to a car is only half the problem. The question is, how can you improve the overall operation of a city based on the data coming off the connected car? Right, connected cars can happen without smarter cities, but smarter cities cannot happen without the connected car. So we need to do something different. If you look at the most recent study, you see that the average age of a driver getting their license over the last decade has increased by 1.5 years. Now think about that. When I was 16, I ran out and got my driver's license the first day that I was able to get it on my birthday. But the average age now has increased by about 1.5 years in the last decade. Young people, are no longer finding the driving experience desirable, whether it's due to cost, hassle, congestion. They're looking for other ways, and this is why obviously things like Uber and ride-sharing services are becoming so popular. But for those of us who make a business selling cars or selling components to the car makers and are in the automotive industry, this is a real problem. It means that our target market is shrinking due to overall cost of congestion. So what I want to do is I want to look at smarter cities and provide a very simple framework for how to think about smarter cities. Now, a lot of people talk about smarter cities. You'll see Cisco and IBM and Intel, and there's dozens of companies that talk about smarter cities. The question is, what is a smarter city? And let me give you a simple 5-level framework in terms of how to think of it. The first level of the smarter cities are those that are starting to get data and seeing what's happening within their city. We call this level 1 cities. A good example here is Bavaria. The region in Germany, in the last 3 months, they started to get vehicle-based data to figure out what's happening on their roadways. And although that sounds very simple, it's pretty revolutionary because 10 years ago, traffic data was literally collected by people looking out the window of helicopters or by governments embedding sensors into the roads. And governments just in North America put $500 million of taxpayer dollars, your money, into instrumenting 5,000 miles of road. So $500 million to figure out what was happening on 5,000 miles of road. Companies like INRIX, we've put $31 million of private capital, and now we provide data on 2 million miles of road. So it's been a revolution in terms of figuring out what's happening on the roadways. You'll notice that your local cities no longer fly helicopters to look out the windows to figure out what's going on. So level 1 cities are starting to figure out what's going on, and that's good. But that's only level 1. Level 2 is what I guess I would point to the Highways Agency in the United Kingdom. This is an example of a whole country that said, we're going to provide a view of what's happening on our roadways across the entire country. So the first time an entire country has used vehicle-based probe data to figure out what's happening on the roadways. But then they went a step further, and they said, beyond just figuring out traffic, let's look at population movement. How are people moving, and where do populations build up? And this was very useful during the Olympics in London and during the Queen's Jubilee. And they were using it then to respond by sending more mass transit, more buses, more trains, to be able to meet basically demand with supply. So this is an example where level 2, they're starting to use data to optimize the overall network. Level 3, we would point to a good example being the I-95 Corridor Coalition. This is an example of a group that's actually applying analytics to make better investment decisions. So I-95 is a road that runs from Maine down to Florida on the East Coast, and there's a group of 16 states that all got together and said, we're going to use probe-based data from vehicles themselves to figure out what's happening on the roadways. But then we're going to go a step further. We're going to use analytics to figure out and prioritize investment decisions. Many of you may remember the bridges to nowhere, right? Infrastructure was funded depending upon, in this country, how powerful your congressman was, right? Could he bring home the bacon? Could he go there and get a bridge? Could he go there and do something else? You'll notice that in the last 5, 6, 7, 8 years, that's kind of stopped in the United States. Well, why has it stopped? And the reason is because now you have real data about where the bottlenecks are and where the worst areas are and what you can do to fix them. So it's very hard for a congressman to go in and advocate for project number 87 on the list if we can't fund projects 1 through 10. And that's where we are today, using data-driven decisions to help prioritize overall infrastructure. And you can use this data to look at congestion patterns, but more importantly, traffic is fairly predictable. Meaning, if you know the time of day, if you know the season, you know the weather, you know things like school schedules, the holiday calendar, all this can be used to give you roughly about 85% accuracy in predicting traffic. So cities are now using that prediction to say, well, what if I add a bridge? What if I add a ramp? What if I redesign this lane configuration? Can I get a better result? And that's exactly what you see happening today. But now let's go a step further. Level 4 cities are those that are now using data to optimize their infrastructure. A good example here is Los Angeles. Los Angeles reduced traffic congestion by about 8% in the last year without building one new road. You want to know how they did it? They did it by optimizing the traffic signal timing across the entire city. So they took real-world data, looking at overall traffic patterns, built a statistical model, and then retimed all of the 10,000 traffic signals across Los Angeles to provide much better throughput for the overall system. Well, that's good. In fact, that was one of the pioneering things that we've seen in terms of the Smarter Cities Movement, or ITS. The problem with Los Angeles is it was a one-time deal. They built a model, they analyzed it, they retimed the signals, and then they walked away. The problem, of course, is city congestion is not a one-time deal, right? It continually changes, right? A new school is put in over here, a business is put in over here, a lane configuration changes, and it fundamentally has a change in terms of the overall traffic congestion in a city. So now we move to level 5, right? The top level of smarter cities. And this is the cities that are using real-time data to influence traffic and congestion and decisions in real time. They basically are building dynamic hot lanes, HOV lanes, congestion-based pricing. They're using things like dynamic ramp configurations to optimize traffic based on real-time data. We've seen this in Seattle, we've seen it in Amsterdam, we've seen it in a variety of other cities as well. Think of this as the Wizard of Oz. If you remember the Wizard of Oz, right, there was the wizard behind the curtain pulling a bunch of different levers to do what he wanted to do. And this is what cities now have. They now are starting to have levers that they can pull to move traffic congestion around an area based on how they want to optimize it. And this is what we call dynamic level 5 optimization. But here's the key. The data to do that comes from the connected car. The connected car is the electricity, if you will, for the smarter city. Without the data from the car, you can't optimize or create this real-world optimization to reduce traffic congestion and make an overall city better. Now, I can't tell you how many meetings I've been in Washington, D.C., where they're talking about vehicle-to-vehicle and vehicle-to-infrastructure. I'm sure all of you have heard the buzzwords V2V and V2I. And I'll be honest, I am a skeptic in terms of vehicle-to-infrastructure. And the reason is because 10 years ago, the whole thing was, let's spend $500 million to instrument roads, build infrastructure, and what happened? What happened is technology moved faster than the government. Surprise, surprise. And private sector invented this idea of crowdsourcing traffic and using probe data to create traffic, and immediately made road infrastructure and road sensors obsolete. You can't find a city in the United States, I bet, that's still building magnetic loop coils into the road to figure out what's going on. And the same thing's here with vehicle-to-infrastructure. They've been talking about it for 15 years, and yet we have a couple pilots going on in Ann Arbor and a couple of other cities. Now you're seeing technology move faster, surprise, surprise, than the government. And you're starting to see this information happen completely based on vehicle data as opposed to infrastructure-based data. You could call it vehicle-to-cloud-to-vehicle, that's fine, or vehicle-to-vehicle, but it's not talking to infrastructure owned and operated by the government. It's happening because people want it. People demand it. They want better ways to do what they're doing. But here's where it gets interesting. I think many people in this room are very familiar with the idea of crowdsourced probe data for traffic. But now you're starting to see probe data being used for other things. Let me give you an example. Weather data. Many of you know that there's weather data available in vehicles. If you have a vehicle with SiriusXM or something else, you can see that the weather today is 77 degrees and sunny or whatever. That's not terribly interesting. What's interesting for a driver is knowing that the vehicle 2 miles ahead of you slipped on the ice, and then being able to alert you to slow down. That's what matters. The very personable information on my route, what's going on. Or that vehicles a mile ahead are hydroplaning because of a downpour or because of a pipe main leak. Those type of things are interesting. And governments have decided, let's go invest in infrastructure so we can figure out the temperature of the roadways and things like that. Once again, you're seeing the vehicle-based data provide a much better solution. Today, INRIX provides traffic data by pulling speed, location, heading from the vehicle bus of, as I said, about 185 million vehicles and mobile devices. We're now starting to pull data related to fog light status, windshield wiper status, traction control messages, external temperature that we use to create granular-based road weather data. But the key is you can't do it on your own. We're working with companies like the Weather Company, which owns the Weather Channel and syndicates data to 500 TV stations around the country, and similar companies outside the United States to create very sophisticated models of road weather. Because the problem is, if a traction control message goes off, you can't assume that he slipped on the ice. It could just be that the guy is speeding or skidding or something like that. Likewise, when a vehicle stops, you can't assume that traffic stopped. He could be on the side of the road with a flat tire. He could be doing a pickup or something like that. Or he could just be on the side of the road looking at a map. So you need to build these statistical models to really figure out what's going on. And that's exactly what's happening today. Weather companies, along with companies like ourselves, are collecting this data. Again, it's anonymous, to provide a much better view of what's happening on the roads themselves and sending safety alerts back to drivers that need it. What about other types of information? One of the most innovative things I've seen in the last 6 months is the use of vehicle-based data to provide parking data. Doesn't make sense until you realize that the average vehicle today on the road, at least on the high-end brands, have about 50 sensors built into them. Right? You know the parking sensors that are used to self-park cars. You know the sensors that go off to alert you that you're getting too close as you're backing up or going forward. These sensors and cameras and other things are now being used to figure out where there's available parking. As a vehicle drives down the road, it can use its camera and its sonar to figure out where there's available parking. But to do that, you need to know a lot of other information as well. You can use information based on the accelerometer of a mobile device to help figure out when somebody is leaving a parking spot based on other information that you know about the driver and vehicle-based data itself. So you see, the vehicle data is not just being used for traffic. Now it can be used for weather, it can be used for parking, and a broad set of other applications as well. And that's why this is now getting exciting. A lot of people talk about the Internet of Things, and if you read the magazines, they come up with these kind of interesting scenarios, right? Oh, when I drive home and I pull in my garage, I want my coffee maker to go on and I want the heat to go up. Okay, but I got a better example. How about we use the vehicle-based data and the Internet of Things to save people's lives? To save people's lives on the roadway for safety and to help them reduce congestion, get to where they're going faster, and do it in a much safer, more efficient way. That's really what we're talking about, and that's why we get so excited about this inflection point that the industry is in right now. Is because everyone talks about Internet of Things in smarter cities, but now you're seeing the bridge being built. The bridge between the connected car and the smarter city. And it's not a one-way bridge. It's a two-way bridge where data is going both ways. In Seattle, we have a drawbridge that goes up and down all the time when boats are going through it, and it's really annoying because it shuts down the one major freeway going into the city for about 30 minutes at a time. Well, it'd be very useful, wouldn't it, if my car knows exactly when that bridge is going to go down, when it's going to go up, and if I'm headed down in that direction toward the city, for it to alert me even before the bridge goes up that it will go up by the time I get there. That's what we're talking about now with smarter cities. So there's a whole bunch of these applications that are now being built that enable this kind of thing. But let me provide 5 tenets that INRIX is following, and I'll encourage other suppliers and other application developers and OEMs to follow as well as we think about this world of connected cars. The first is that these applications have to be intelligent. The problem with the HMI of most vehicles today, as most of you know, is they're pretty dumb. I get in my car, which is a fairly recent model vehicle, and when I'm going to work, if I want to know the traffic, I have to actually type in my work address, for it to give me a route, then give me the color and the status of the traffic on my way to work. Are you kidding me? I know how to get to work. I drive it every day. Why do I have to punch buttons for it to tell me that? Why is the vehicle not smart enough to know that every morning at 8 o'clock in the morning I leave my house Monday through Friday and I drive to work? And at every day about 6:30 I leave my work and I come home. And it should automatically display, hey Brian, I think I know where you're going. Here's the information you need to know. You're going to be at work at 8:10, you're going to be late to your first meeting. Right? Those kind of things are what people really want. And that requires an interesting level of intelligence that needs to be built into the car in these applications. The second important tenet, which I think the previous panel did a good job discussing, and that is these applications have to be integrated with vehicle data. Right, I know there's a lot of talk about Google and Apple, and that's interesting, and it'd be fun to have Twitter in my car or whatever, but that's not really what we're talking about. I think what the OEMs care most about and what consumers care most about are those applications that integrate with vehicle data, like I said, that help them do what they want to do, that help them get from point A to point B faster, that help them park faster, that help them take a safer route, those type of things. And that requires integration with the vehicle bus, and doing that in a very private way where that data is not made available to other people for using in advertising, tracking, or whatever else. That's why that data is so important. The third tenet, though, is community. Community is critical to all these scenarios. When we started INRIX with this idea of crowdsourcing traffic data, I remember a couple OEMs said, well, we're going to use our data to create our own traffic data so that no one else can benefit from it. Well, the problem is that's not terribly useful. This is a network effects model where the more vehicles in the network, the more exponentially valuable the network is for everybody. Right? Knowing that there's another car of your brand 3 miles ahead that's going so fast isn't terribly interesting. What's more interesting is if I have all the vehicles that are telling me where they're at and how fast they're going, so I can create much better data. And that's what you're seeing today, and that's why this model has worked, where today the vast majority of automotive brands contribute data anonymously to this INRIX network and other crowdsourced networks that then produce traffic information that's beneficial for everyone. But the same thing's true for safety data. It's not terribly useful if the car ahead of me, if I only know that there's another car brand like mine that slipped on the ice, I want to know if anybody slipped on the ice, because it's safety. That's so the societal benefit grows exponentially with the number of people in the network. The fourth tenet is about integration with your mobile phone. Not necessarily projecting the display of your mobile phone, because there's different use cases, but what you care about is knowing your calendar and your contacts. Right? I want to know as I'm getting in the car that I'm going to be late to my first meeting, and oh, by the way, Brian, should I let the first 2 people know in that meeting you're going to be late? And have the car send that message, whether through text or through email. The car should be that smart, where it should be able to say, as soon as I get in it, hello, Brian, I think you're going to work. If you are, you're going to be there 10 minutes late. I noticed that your first meeting starts and you're going to miss it. I'll send a message to the people in that meeting. That's not a very difficult scenario when you integrate with the calendar and the contacts on the phone. Those type of applications, though, you will see this year. This is where I get very excited, is all these things are sort of coming together at the same time. And then the fifth tenet, and probably the most important, is simplicity. I think all of us know that cars and the HMIs are just too complicated. And there's reasons for that. Right? The previous panel talked about different protocols and different integration and different vendors trying to integrate everything together. But simplicity is absolutely the key. You know, I worked at Microsoft back in the 90s, and we had an automotive PC in 1996. We had a tablet computer in 1998. What was the difference between then and now? The difference is simplicity. Apple figured out how to make a tablet simple. Right? You're now starting to see these vehicle HMIs simple. And I think Tesla's done a very good job of creating a very simple HMI in the vehicle that's quite compelling, that a lot of people obviously are drawn to. So let me wrap up. The key about what's happening today is these trends are coming together at the same time. We see the vehicle becoming more and more connected, and I think almost every analyst puts the number well over 50% within the next 3 years of vehicles will be connected. But what's happening now is this bridge is being built between the car and the city The car talks to the city, provides information that's being analyzed, and the city's talking to the vehicle. That bridge now exists. And that's where it gets exciting, because now you can have a real societal impact, a real impact on improving people's lives by making that bridge and connecting those two bridges together. And that's why companies like ours aren't just focused on automotive. We're focused on automotive as well as public sector and enabling these kind of scenarios, which is quite interesting. The key is the connected car becomes the electricity for the smarter city. So a lot of people talk about what can you do with the vehicle-based data, and there is a whole bunch of different scenarios. Turning on my toaster or my coffee maker may be one of them. But the most compelling one is to make life better for everyone. And let me wrap up with a simple story. And this came from the head of the Department of Transportation in North Carolina. About a month after North Carolina started connecting vehicle-based data and integrating it to the real-time incident response system. So they basically have a traffic management center that is now getting real-time information about vehicles. They detected that there was something going on up in the hills near Asheville. And they called us up and they said, INRIX, you're wrong. There's something wrong with the data, there's a bug, and we're going to go up there and we're going to take pictures and we're going to prove you wrong. So they sent an incident response vehicle up there to take pictures. And what they found is that there were two jackknife semi-trucks that had collided. And they were able, with their incident response truck, to take those people to a hospital. And the head of the Department of Transportation got up on stage and he says, because of this vehicle-based data, we were able to see something that we didn't know was happening. And as a result of that, we can name at least 2 people that were involved in that wreck that are alive today that wouldn't have been alive otherwise. That's what we're talking about. The other scenarios are kind of interesting, and Wi-Fi in the car is great. But we have an opportunity as an industry to fundamentally save lives, to fundamentally reduce one of society's biggest problems, and to fundamentally transform our cities into smarter cities by integrating them with the vehicle itself. And that's why I think this is so exciting. So with that, let me stop and ask if there's any questions.
Do we have any questions at all for Brian?
Oh, okay.
Good. Hey, Brian. Great talk.
Thanks.
Among all the cities in the US, which city is like the most pioneering in adopting the smart city, especially the traffic? That's number one. Mm-hmm. Number two is, what's your business model working with cities?
Sure. So what's the most pioneering city? That's a bit of a loaded question, of course, because different cities are doing different things. I'll make a generalization, though. The cities on the East Coast and the West Coast are far more advanced than anybody else in the middle of the country, which is unfortunate. LA, probably one of the most innovative in terms of doing modeling, and I said around traffic signal timings. Seattle is probably the most innovative I've seen in the United States in terms of dynamically trying to control the flow of traffic based on basically pulling a bunch of different levers. But on the East Coast, they're much more advanced in terms of looking at analytics to figure out what's happening and where they can improve. So a bunch of different examples, but like I said, it's typically Seattle, Los Angeles, San Francisco, and then the cities on the East Coast as part of the I-95 coalition. The second question is, what's our business model in working with cities? Same thing as it is with working with car makers, right? We take data from cities and from car makers, analyze them, put them together, and then we sell solutions to both. So INRIX as a company sells analytics applications to cities, we sell applications to car makers, we sell to media companies and a variety of other folks, and that's how we make our money.
So for the first question, do you have any insights on other countries in terms of their need to adopt this smart city?
Yeah, exactly. So it's interesting. Some of the most innovative cities in the world, a little bit counterintuitive, are in the developing markets, specifically China, Moscow, and in the Abu Dhabi, UAE, Kuwait area. Now, why is that? Part of it is because they've got a real problem. I mean, if you think traffic is bad here in the United States, if you rank the worst cities in the world, New York and LA don't even make the top 10. Cities like Sao Paulo, Moscow, Beijing, Shanghai are much higher on the list. So they have a much bigger problem. And as these cities are developing and as the populations are growing, they're using money to invest kind of ahead of the curve. It's a little bit like, why is Turkey one of the most connected mobile countries in the world, and it's because they started later. And they were able to build an infrastructure based on new technology. And you're seeing that today in these developing countries, which are some of the most advanced, smarter cities on the planet.
Thank you.
Yep.
Hi, Brian. I'm from India, Track and Tell. I wanted to ask you, you mentioned you were collecting data from cars and mobile phones. Can you tell me a little bit more about how you actually collect the data? So like if Audi has a connected car and it has, it's got that data, how are you getting access to that data?
Yeah, so our model is quite simple. We provide these applications and solutions to, say, car makers and mobile phone carriers and mobile application providers, more than 350 different customers, many of which provide us data back anonymously. So we sell applications to, say, a car maker, and then we discount our prices depending upon the amount of data we can get back. And then we use that to improve quality of service for everybody else in the network. So to answer your question, we do collect data anonymously from as many different places as possible, which includes automotive customers, it includes mobile application providers that use our data, it includes cities that we get data from, and really hundreds and hundreds of different sources. There's about 600 different distinct sources that we're collecting data from on a real-time basis every day.
Okay. Thank you.
Okay, so we've got time for one more question.
Thanks. Hi, Brian. Catherine McCullough, Intelligent Car Coalition. I was wondering, you had mentioned that you had spoken with the government about V2V. Are you also concerned about how the government, for instance, the FTC, is looking at data and their concerns about how it might be handled with connected vehicles?
Well, so it's interesting. There's a lot of talk, obviously, about privacy in the public sector and privacy of data and things like that. Quite frankly, and again, I've spent a lot of time in Washington, D.C. I was an advisor to the Secretary of Transportation in D.C. for a while. The problem's not going to get solved in D.C. The problem's going to get solved in this room by the OEMs making decisions about what they're comfortable with and what they're not comfortable with. It's as simple as that, right? Is an OEM comfortable, for instance, giving all of its vehicle-based data to Google? That's a decision that the government's not going to make, the car company has to make. Are they comfortable giving anonymous data to help overall people and safety? Most OEMs are going to say yes if it's anonymous and I can control what data is being collected. And of course, I benefit from it in terms of selling unique features to the people who buy my vehicles. So, again, I've seen time and time again, having been in this industry for about 20 years now, where the private sector tends to move a lot faster than the government in a lot of different cases like this. And the privacy issue in particular is going to get solved years ahead by OEMs and what they're willing to do rather than legislation coming out of DC.
Okay, thank you very much, Brian.
Thank you.
So now we have a lunch break. Lunch will be served at the back of the exhibition hall. So if you go through these two gaps here, we're going to reconvene at 2:25. So we'll see you back then. Thank you.